All right, so question 2, or example 2, we're going to create this piecewise function. So if you need to graph it out, go and graph it out really quickly and then pause it, graph it out, and then come back. All right, so here we're going to go ahead and take a look at this piecewise function and actually create the two pieces, because we know we have a function here, a function here. We're going to create those two pieces there, find the domain and all the good stuff, and then put them together and create the piecewise function. All right, so with this, the first step again is always to tell what are the parent graphs or parent functions. So here we should notice there are two different functions here, two different parent functions. So one is this first part right here. That is the square root function. Square root function. Woo woo. We got that part going on right there. All right, so then the other part is our exponential function. Sorry, our cubic function. It's cubic. So with that again, everybody should know these because we've been going through these for a while now. All right, so we have our cubic function. So we're going to deal with the square root function, then we're going to deal with the cubic function, and then go from there. So we're going to go to step 2, and we're going to deal with our first equation. Let's do first equation. And the first equation, the first step says to list the transformations that are happening here, and then create the actual equation. So here, we already know the parent function is square root, and that normally goes, where's 4? Sorry, this is 2 right here, this is 4 right here, so we got something that goes like that. That's our parent graph. So with that, really nothing changed. It looks pretty much the exact same there. But the only thing that happened is that it moved to the left, and this is 2 spots. That's 4 there. So we moved to the left 2. Okay, so we're going to write that down with left 2. Again, it didn't shrink or expand. It didn't actually move up or down. It just went left. All right. So there's no other transformations happening here. It didn't flip or anything of that sort. So let's go ahead and write the equation for this. Again, we know it's square root. And again, here, we're talking about this function here. And we did our transformations. This is what we looked at. And we said, okay, if it goes left to right, it's the b. So here, when we take a look at this part, we're going to take a look at the b portion of it. And again, opposite of what you think. So if it goes to the left, it's normally negative. But this time, it goes opposite of what you think. So here we're going to write it so it's a positive. So there's no a, so we leave it alone. X, and again, positive 2 because it goes opposite of what you think. And then there's no c, so we just leave it. Okay. All right, so then let's go to step 3. And again, this is all for equation, the first equation. The step 3 says find your domain of it, of the function. Domain. All right, so we find our domain of the function here. Oh, I need those numbers. That's the negative 2 right there, negative 4 here. We have 2, we have 4. I need those numbers back. All right, so if we look at our domain, we talk about where it starts and where it stops. And so here, when we talk about where it starts and stops, it starts here, it stops there. All right, and so again, we are looking at the x values for domain. Domain is your input, your x values, has nothing to do with y. So here, when we talk about our domain, it starts at negative 2, and it ends at positive 2. And remember, if it's between, because we're shading between here, the graph is between those two. So if it's between, we use this part here. And we have to figure out, okay, is one of them equal to, or are they both just less than signs? If we look at this part and the whole thing about open and closed circles on the endpoints that we've been talking about, let's open a circle on this part here. So that means it's just a less than sign. It's a closed circle there, which means it has to be an equal sign. So that's again why when we were graphing it and making the tables and we were talking about open and closed circles when it comes to the endpoints, that's important right there. Because if not, that means this graph would actually be wrong if we put just the less than sign. We wouldn't have graphed out, we wouldn't have the right graph for the right function. So here, let's go to put everything together really quick. All right, so we have that. Wonderful, wonderful. All right, so then let's go to equation 2, the second equation. All right, so for our second equation, we're going to go ahead and start with step 2 again. And we're going to look at our transformations that are happening with our second function, which is our cubic function. So I'm going to go ahead and get rid of this part here. We don't need that. Look at our cubic function here. So here, we know the cubic function. I need you guys. Oh, get out the way. Move, get out the way. All right. So with our cubic function, we know that it starts here at the origin, and it normally goes up this way. It goes down this way. So it kind of still looks the same there. So we didn't change anything. So we're not going to change anything with the A's or shrinking, expanding, or condensing, or vertically shrinking, vertically expanding, whatever. None of that's happening here. So with that, we're not going to deal with any A's, so we don't have to worry about that part. All right, when it comes to going up and down, left and right, it's doing something. It went to the right 4, because this right there is the center. So it went 4. It didn't go up or down. And it does not flip, because if it flipped, that means this side would go up and that side would go down. But we didn't do that. So here, it didn't flip. So all we have is just that it moved to the right 4. So let's go and write the equation that shows that it moved to the right 4. Again, it's cubic. And if we're talking about the transformations and what we've done before in the past, we have this. And so there's no A, there's no C. All we're doing is moving left to right. And so here, when it comes to this part, no A, we leave it. It's goes to the right, which remember B goes opposite of what you think. So if it goes to the right, it should actually be a minus 4. And then there's no C, so we just leave it as it is. All right, and then step 3 says, okay, now that we have that function that we created with that one transformation, let's go and find our domain of that function. All right, so from this part, again, domain looks at go from left to right, not from bottom to top, but left to right. All right, so I'm gonna pull this off to the side there. Don't need you right now. Let's get rid of you guys. Boom, boom. All right, so with that, if we're talking about our cubic function, we know it starts here. Oh, I got no color. Starts here, ends here. So we're looking at our x values from left to right. It starts at 2 and it ends at 6. So from 2 to 6, the function exists. That's your domain from 2 to 6. And again, it's between, because the graph is between those two sections. And we just have to figure out, okay, what is the actual less than or equal to sign portions of it. So at 2, it's an open circle right there, so we can keep it as a less than sign. At 6, x equals 6 there, at x equals 6, it's a closed circle. So it means we have to have a equal to sign right there. Okay, so for this function, we're going to write it out again with our domain. All right, we have that. All right, so we get that whole function right there. All right, so the biggest part is now, let's go ahead and put everything together and make it one big function, and then we're good. So we do the square root of x plus 2, and you can do if or for or not even put anything down there, except for just the back part. So you will see it depending on whatever book you're dealing with, whatever website you're looking at, it could show either one of them. So I want you to be prepared that no matter what, it doesn't have to have the if or the word for or anything of that sort. It could just be like this. And they still expect you to know what the piecewise function is and how to graph it and everything. How to evaluate pieces of it and everything. All right, so that is it.